Hi, this instructional video is about writing rules for the arithmetic sequence. Writing rules for the arithmetic sequence. So, what's an arithmetic sequence? If you're given a set of data, a set of numbers, for example, a sequence like 2, 4, 6, 8, so on and so forth. If the difference between those set of numbers are constant, like in this case, between 2 and 4 is 2, 4 and 6 is 2, if the difference is consistently the same, then this sequence of numbers is said to be an arithmetic sequence. Another example, for example, in this case, let's say, suppose we have 52, 45, 38, and 31, and 24, so on and so forth. Then you notice in this case the numbers are getting smaller, and the difference between the two numbers are reducing by 7. So in this case it's -7. And those differences in a given sequence is called a common difference, denoted by a letter D. So the common difference, D, is -7 in this case. Common difference between these set of numbers is 2, because it's increasing by 2. And to find or write the general rule of an arithmetic sequence, the standard or the general rule is given as A of n is equal to A of 1, that's the first of the sequence, plus the given position n minus the 1 times the difference, the common difference. So in this case, let's say here, the first initial number is given as 2. So if you want to write the general rule, you'll say A of n is equal to the first number, 2, plus n minus the 1 times the common difference of 2. And you apply the distributive property. So that becomes 2 plus 2n minus the 2. And in this case, the additive inverse, 2 and -2, cancels. So the general rule for this particular one will be written as A of n is equal to 2n. So it makes sense. What's the first number? Well, put 1 in there. It's 2 times 1. That's 2. What's the second number? Put 2 in there. 2 times 2 is 4. Same as over here. Again, same general rule. And this time, the first number in the sequence is 52. Plus undetermined position, so we're going to figure that out later, times the common difference of -7 this time, because this is reducing. The distributive property, so we get 52 minus the 7n plus the 7. Combine the like terms. In this case, we get the general rule as 52 plus 7 is 59 minus the 7n. That's the general rule. So, what's the first sequence of the number? Well, put the 1 in there and goes 7 times 1 minus the 59 is 52. What's the second position? 7 times 2 is 14, and 59 minus 14, well, that's 45. There it is. See? So this general rule holds true. Oh, yeah, right there. That being said, I realized number 1 is, very doable. So let me try number 3 to give you a demo of how this works. First, you have to determine, are these set of numbers, the difference between those, are they consistent? Are the differences constant? And it turns out between these two fractions, it is reducing by 2/3. Well, let me show you why. 5 over 2 minus 11 over 6. The common denominator is 6. So multiply the 3 here, multiply the 3 there. So that becomes 15 over 6 minus 11 over 6, which is what, 4 over 6? And doesn't the 4 over 6 reduce to 2/3? But since it's decreasing, I say minus 2/3. And what's the difference between those two quotients? 11 over 6 minus 7 over 6, isn't that 4 over 6? And again, then we just say 4 over 6 reduces to 2/3. And it's negative because it's reducing, it's getting smaller. So the common difference between these sequences is -2/3. What's the first number, the initial number? The A of 1 is equal to 5 over 2. Now we could take this information and write the general rule. So the rule is A of n is equal to A sub 1 plus n minus 1 times the common difference. The first initial number, A sub 1, is 5 over 2 plus n times 1 times the common difference of -2/3. And so you do this distributive property, that becomes 5 over 2 minus the 2/3 n plus 2/3. Combine like terms. The common denominator is 6. So that's going to become 19 over 6 minus 2/3 n. And that is a general rule. So if somebody asks you something like, find the 25th of the sequence. If this is 1, 2, 3, 4, 5, so on and so forth, what number will be on the 25th position? So all you do is simply say a to the 25th is equal to, using that rule that we just came up with, 19 over 6 minus 2/3 times the 25th position. And you evaluate. So that becomes 19 over 6 minus, 2 times 25 is 50 over 3. Common denominator between those two is a 6, so multiply the 2. So you get 19 over 6 minus 100 over 6. So what is that 25th position given this general rule? It's going to be negative 81 over 6. Whatever this is, it's getting smaller and smaller as we go further into the sequence. Alright, so then, why don't you try numbers 1 and 2? Okay, so you said, alright, this one is more doable. The numbers are increasing as the sequence goes further, and the difference between them from 6 to 14 is increasing by 8. 14 to 22 is also 8. So since the difference, they're all constant, okay, this is an arithmetic sequence. So the common difference is, of course, 8. The first of the sequence, a sub 1, is 6. Now we have enough information to use the general rule. A sub n equals a sub 1 plus the difference of n minus the 1 times the common difference d. The first of the sequence was given as 6 plus n minus 1, and the common difference we said it was 8. The distributive property, so we get 6 plus 8n minus the 8. So the general rule for this given sequence is 8n is equal to 6 minus 8 is negative 2 plus 8n. So we could apply this general rule to determine what the number will be in any given sequence position. So once again, let's say, what's the 25th position then? So then we go a to the 25th. And that will equal negative 2 plus 8 times the 25th position. So if I have 4 quarters, I know that's 100. So since I have 8 quarters, that will be 200. So what would that position be on the 25th? What number would that be? That would be 198. Can you imagine having to count all the way to 25th position, let alone 100 and 200? That would be quite daunting, huh? This will make it a lot easier. The magic of arithmetic sequences. How about this one? So we go fraction whole, fraction whole, fraction whole. Either way, the numbers are increasing. Okay, because 1/2, 3 is like saying 6 over 2. 11 over 2, this is like saying 16 over 2. So it's increasing by, well, 2.5, I guess. 2.5. So the common difference is, in fact, 5 over 2. And the initial number was given as 1/2. So we use the general rule. A sub n is equal to a sub 1 plus n minus 1 times the common difference d. Plug in some numbers. The first number was 1/2. Plus n minus 1 times the common difference was 5 over 2. To the distributive property, we get 1/2 plus 5 over 2n minus 5 over 2. We have a common denominator, so we combine the like terms. 1 minus 5 is negative 4. And negative 4 over 2 reduces to negative 2 plus 5 over 2n. And that's a general rule that we could apply for this given sequence. So let's do it again. What number will you have on the 25th position? So you go a to the 25th is equal to negative 2 plus 5 over 2 times 25. Well, that become a so 25 is equal to negative 2 plus, what is that? What is that? 5. 25? What is that? 525. Here we go. 125 over 2. And isn't that like saying, oops, since negative 2, that's a negative 4 over 2. So isn't that like saying 121 over 2? There we go.